Let's just jump into it. So I wanted to solve lead code questions and I thought let's do it together. I'm going to solve the very first question, number one, because why not? So it's quite easy. Let me just go through the question real quick. You have an array, let's say 2, 7, 1, 1 and 1, 5, 11 and 15. And you have a target, let's say 9 according to this example. And what you have to do is you have to find two numbers such that in this case 7 and 2 which whose sum equals the target, which is 9 in this case. Pretty easy, right? So there are three ways to do this. Number one will be normal brute force and squared method, where we have two loops and we exhaustively search every single possible solutions, which is very bad and I'm not going to go through that. Second option is using pointers. Let me just write that 271. Yeah, so we have two pointers, one at the beginning and one at the end. So before we start, this solution assumes that the array is sorted. So before we start, we have to sort this array, which will take big O of n log n. If you're using the inbuilt Python sorting method. So after sorting, you take two pointers, one at the beginning and one at the end. Let's name them P1 and P2. And while P1 is less than P2, what we do is if P1 plus P2 is greater than target, then we move P2 one number now down. Else if P1 plus P2 is less than target, then move this one up, else just return P1 and P2. Now the problem with this obviously is it will take a time complexity of at least n log n because of the sorting part. In this problem statement, they haven't mentioned that the array is sorted. Also, this example is not sorted, which means there is another solution that takes big of n. Let me just go through that real quick. So this is called dynamic programming. This solution is called dynamic programming, something called memorization, which is we memorize what we have seen. So basically we need a hash map for it. And let me just write this example: 3, 2 and 4, and we take a pointer p and we need the target, that is 6. So what we'll do is we take whatever there is in the pointer p, target minus p, which is 6 minus 3, in this case 3. We will check that this 3, that is t minus p, exist in this hash map. If it doesn't, we add 3 into the hash map. Okay, so say similar for 2 minus 6 minus 2 is 4, and there is no 4 in this hash map, so 4 goes in. Actually, hash map is key value pair, so the number 3 will be key and the value will be the position, which is 0, 1 and 2, 0, 1. And when p equals 4, 6 minus 4 is 2. Sorry, it's 2 here. 6 minus 2 is 4, and we have 6 minus 4 is 2, and we have a 2 here corresponding to position 1. In this case, we will return p and hash map at position t minus p, and in this case we will return 2 and 1. And you can see here they're not caring about the order of the answer, so we can return 2 1 instead of 1 2. So first of all, we need a pointer pointing at 0, but we don't need to do this because Python is awesome. For I, for pointer and the number in enumerate nums t minus t equals target minus p, and t if t in hash map, then return what? Return p, and that whatever position that t is. Else we will add the current number to hash map and point that to the position p. So that's all, I think. Let's just run the test code. That's right. So in Python, you can just basically say hash map as a dictionary. Same thing in Python. I mean, not exactly same thing, but same principle. And as you can see here, we are having a wrong answer. Why is that? At this point in time, we add a single print statement which will print the target minus p, which number it is. It's target minus n, not target minus p. So that's it for this video, and I will solve next, which is add two numbers in the next video probably. Bye. Oh yeah, so subscribe, like, comment, and all those things that YouTubers say. Press the bell icon. That's it. If you want to learn more about data structure, comment down below, and we have videos about arrays and skip list. You just press that I over there, and yeah, that's it. Bye.